I want you to imagine looking at a field with superhuman vision and seeing all the living organisms inside it. Maybe you see insects feeding and buzzing around down to the tiny bacteria living on plants. Now imagine how disappointed you'd be if instead all you could see was with your normal eyes again. You'd lose a significant amount of information about what is happening within that field. The exciting part about this is that this superhuman vision isn't that far off. Scientists are beginning to use this technology in the agricultural sciences. It's called hyperspectral imaging, and it uses multiple high-definition sensors to collect information over a large range of the light spectrum. This is possible because we're constantly being bombarded with many forms of visible and non-visible light from the sun. X-rays are a good example of this non-visible light because we can use them to diagnose broken bones in the body that we can't see with our own eyes. We can then extrapolate this concept to the entire electromagnetic spectrum, which is really just a term to describe all of these forms of visible and non-visible light. So this technology is being developed mainly because growers in many agricultural industries aren't able to produce adequate crop yields due to more unpredictable climate factors, invasive insect species, and the transmission of plant diseases by these insect species that are economically devastating to growers. So to estimate the impact of these insects and diseases, growers have to go into their fields and survey for damage weekly, which is really costly and time consuming. So because of this, growers have resorted to making unilateral pesticide spray decisions, like spraying pesticides based on the information gathered from sampling just a few of their fields instead of sampling all of them, which is not a sustainable approach in the long run because in many cases it results in unnecessary pesticide applications to the region. In my thesis, I'm trying to use drones fitted with hyperspectral imaging equipment to identify plants and insects in agricultural fields by what we refer to as their spectral signatures, which is like a fingerprint of how light reflects each person or object. Currently, I'm collaborating with scientists at the Rochester Institute of Technology Imaging Center to detect onion thrips, which are tiny insects that feed on the sap of onion plants and, like I mentioned earlier, transmit harmful viruses. In one study using hyperspectral imaging, RIT researchers were able to identify a fungal disease called apple scab on the near ultraviolet portion of the spectrum 5 weeks before the plant showed visible symptoms. So this level of detection is a real paradigm shift in pest management because the degree of management often comes down to how much information a grower has and how quickly they can act on that information. So this technology is really going to give them the leg up they need to accurately survey their fields with these drones in just a few hours and make economical spray decisions. It will also allow them to protect their crops by detecting signs of pests and disease before their plants even show visible symptoms. Now, I hope that you can see with your new superhuman vision that seeing really is believing if you know where to look. Thank you.